This is section 7.5, the method of partial fractions decomposition. We will try to integrate a rational function using this method, and we will look at case 2 this time in this video. That means case 2 is when we do have a proper rational function and denominator is a product of a linear factors, which actually some of them are the same, are repeated. Okay? That means we will have factors like ax plus b, and they are repeated exactly the same factor like r times. That means, for example, we can say ax plus b, a1x plus b1 to the power of r, and we can have to the power of 2, 3, 4. Now we have to make sure that we will fully decompose this rational function. That means the following are the partial fractions, partial fraction decomposition. We can see we will take the first factor, and then we will take the same factor to the power of 2, and then the same factor to the power of 3 as a denominator of the partial fraction, and then we will keep working until we reach the final power, final exponent. Okay? And of course, on the top, we will place the constant because numerator always has to have 1 degree less than the denominator. If this is to the power of 1, of course, is the linear factor, then this will be just a constant. Okay, let's maybe take just a rational function, x squared plus x minus 5 all over x minus 1 times x plus 4 squared. And let's just try to do the partial fraction decomposition. So we see 2 linear factors. I mean, we have to be careful because we see 3, right? But we see 2 different. We can see x minus 1, we see x plus 4, and since it's taken to the power of 2, we have to repeat it. And we will place the constant a, b, and c. However, when we look at this, yeah, they are the same. That means doesn't make sense, because thinking about backwards, the common denominator for this is just x minus 1 times x plus 4, which is not square. Okay? That's the reason that we have to take the second factor of the repeated one to the power of 2. Okay? If this will be, let's say, to the power of 3, we will keep working and we will place the same factor to the power of 3. That we can see to fully and properly decompose the proper rational function, we will include power 1, 2, and 3 because it was 3. And of course the constant. And we don't have to be worried because the common denominator for those 3, of course, is x to the power x plus 4 to the power of 3. And when we make the common denominator, the top, the numerator, it will be polynomial 1 degree less, definitely. That's the reason that we have to put still a constant on the top. Okay? We will not put the linear terms. Okay, but please remember to fully decompose. And maybe one more, just to check, and then we will integrate. X cubed minus x plus 1 over x squared, x minus 1, let's say to the power of 4. Okay, as we can see, we have x squared. This means that we will expect a denominator x and x squared. Then x minus 1 to the power of 1, x minus 1 to the power of 2, x minus 1 to the power of 3, and to the power of 4. To the power of 1, to the power of 2, to the power of 3, to the power of 4. And everywhere, in this case, A, B, C, D, E, and so on, F, everywhere on the numerator we will place just the constant. Okay, and now will be much easier to integrate. However, finding the coefficients A, B, C, D, E, F, it's a little bit of pre-calculus required, a little bit of algebra. Okay, let's integrate example number 1. 3x squared minus x minus 2 all over x minus 2 over times x minus 1 squared. That means, first of all, we see that this is squared, this is second degree, this is second and 1. When we distribute, we will get cube. That means it's definitely a proper rational function, because we have to make sure that we have proper rational function. Okay, how many partial fractions we expecting? 1, x minus 2, x minus 1, and also x minus 1 to the power of 2. And then everywhere, constant coefficient. Okay, and let's try to find A, B, and C, and then we will integrate. That means, how can we set up enumerators? On the left-hand side, numerator is 3x squared minus 3x minus 2. Now, if we will get a common denominator on the right-hand side using these partial fractions, what we will do? Looking at denominators, actually, it will be the same. Common denominator is x minus 2 times x minus 1 squared, because this one is included here. So let's think. The first fraction has x minus 2 only, which means x minus 1 squared is missing. I have to multiply the numerator and denominator, which we taking care of the numerator. I will multiply a by x minus 1 squared, because this part is missing. Now b. b has x minus 1 as a denominator. Then we're missing one extra x minus 1 and x minus 2. That will be the common denominator if we will multiply by x minus 1 and x minus 2. And c has underneath x minus 1 squared, it's okay, and we still need x minus 2. Okay, now let's pick the value of x. I will pick 1. And if we substitute to this equation, we will get 3 minus 2. This a will be 0, b will be 0. 1 minus 2 is negative 1 times c, which means c is 2. Nice, really nice. Now let's pick the value 2 instead of x, and let's substitute. 2 squared is 4. 4 times 3 is 12. 2 times 3 is 6 minus 2. 2 minus 1 is 1. 1 squared is 1. 1a. 2 minus 2, 0. 2 minus 2, 0. Okay? It means a is 6, 4. Okay. Also not bad. And then, since one of the terms is repeated, we only have 1 and 2 as a roots of the denominator. Then we can pick a random number. Let's pick 0, of course. Nice and easy number. 0, 0, negative 2 on the left-hand side. 0, negative 1 squared, positive 1a. Negative 1 times negative 2, because x is 0, will be positive 2b. And then 0, negative 2c. Negative 2, a is 4, 2b, and c is 2. 2 times 2, 4. Then we can solve for 2b. Oh, actually, negative 2. b is negative 1. Okay, that's not bad. The algebra was actually not bad. Okay, let's see what we have. We have integral of 4x minus 2. b is negative 1, x minus 1, and c is 2, x minus 1 squared. Okay, now let's integrate. Of course, the first integral we can keep constant for, and natural log of x minus 1, because derivative of x minus 1 is 1. Then negative 1, negative 1 natural log of x minus 1. Negative 1 ln of x minus 1. And this one, we have to be careful. I will put 2. We have quantity x minus 1 to the power of 2. If we will let u to be x minus 1, du is dx, we will end up with the integral of 1 over u squared du, which is u to the negative 2. I will copy this, natural log of x minus 1, and then u to the negative 2. I can even write this, u to the negative 2. The integral will be u to the negative 1 over negative 1, which is negative 1 over u. And actually, instead of u, we can substitute back x minus 1. Okay? Well, that means a little bit different because it's not natural, it's square, not natural logarithmic. But yes, we did fully decompose the proper rational function and we did solve the integral. Let's do one more and then you will practice. Okay, oh, looks long. 3x cubed plus x squared minus 8x plus 3 all over x squared and x minus 1 squared. Okay, that's what we can see. We have x squared, which means we have to get a partial fraction with the denominator x and then x squared. We will need x and x squared. And the next one, we will need x minus 1 to the power of 1, x minus 1 to the power of 2. And in this case, all of the terms are the linear, they are just repeated. We will put a constant, a, b, c, and d. Okay, let's try to find them. I will copy numerator, 3x cubed plus x squared minus 8x plus 3. And now, the process of getting common denominator. The common denominator, of course, is x squared times x minus 1 squared. So let's look at the first fraction. A is divided by x only. That means we need 1 extra x and we need x minus 1 squared. A, I will multiply by x and by x minus 1 squared. Okay. Now B. B already has x squared. That means only x minus 1 squared is missing. C has denominator x minus 1. And we need x minus 1 squared, then 1 extra x minus 1 and x squared. And D has x minus 1 squared, only x squared is missing. Okay, what we can do, because we also have a different method, but no, let's stick to the same method. I will pick instead of x 0 first. Let's see the easiest one. 0, 0, 0, 3. That's 0. This will be 0, 0, negative 1. Actually, B. B is 3. Let's write this way. Good. That's nice and easy. Now, of course, I will pick the other and actually the last 0. I will pick 1. It will be 3 plus 1 minus 8 plus 3. 0, 0, 0. D is multiplied by 1. And what we have, 3, 6, 7. 7 minus 8 is negative 1. That means D is negative 1. And now we, of course, run out of the zeros. We have actually 4 coefficients, A, B, C, and D, and we have only 2 zeros. And we will pick the random number. The easiest number that I can think of is 2, or maybe negative 1. We will pick the second time, 2. 2 cubed is 8. 8 times 3 is 24. 2 squared is 4. 2 times 8, 16, plus 3. That will be 1 times 2, 2a. 2 times 1 is 1b. And this will be 4 times 1, 4c, and this one will be also 4d. So what we can do, we have, I can maybe do 28 minus 13, 2a, and b is 3. We can put 3, 4c, and d is negative 1. I mean, we have 15 on this side, and 2a, this is simply 3. 3 minus 4 is negative 1. We can add 1 to both sides. Maybe I can do. Okay, let's see. We got 2a plus 4c equals to 16. I know I can probably divide by 2, but I will keep it for a second. That's we have a system of 2 equations. We need another one, and then we will get a and c. Okay, let's maybe do on the side. I will put negative 1 and substitute, of course, here. Let's substitute negative 1. Negative 1 will give me negative 1, negative 3. Negative 1 squared is 1. Negative 8 times negative is 8 is positive, and plus 3. And negative 1 will give me negative 2, 4. But negative 1, negative 4a, negative 2, negative 4, negative 4a. Okay, negative 4a, negative 1 and negative 1, negative 2 squared, positive 4b, negative 1, this will be positive, negative 2c, and negative 1 will be positive d. Okay, we have 9, negative 4a, and then b is 3 times 4, 12, minus 2c, and d is negative 1. Okay, I can add 4a to both sides. I can add 2c to both sides. 12 minus 1 is 11, and subtracting 9, it will be 2. Okay. What we can do, we can actually divide one of them. Let's divide this one by 2. This will be a plus 2c plus 8. And when I put the second equation underneath, we will have 4a plus 2c equals to 2. Yes, I just did this. Now we can subtract because we have 2c and 2c. When we will subtract, we will hopefully get equation with just a being unknown. Okay, that means a minus 4a is negative 3a. 2c minus 2c is 0. 8 minus 2 is 6. Okay, a is negative 2. A is negative 2. If a is negative 2, we can compute c. I know, lots of algebra. Actually, I can write here 2 times negative 2 plus 4c equals to 16. 4c equals to, this is negative 4. Adding to both sides, we will have 20. C is 5. Okay, let's just save the space, and we will do this way. A is negative 2. B is, do we have B? B is 3. C is 5. And D is negative 1. I will put the final answer. Let's try. This is negative 2 over x, negative 2 ln of x. This one is positive 3 and 1 over x squared. This means that x is taken to the power of negative 2. Integral of x to the negative 2 is negative 1 over x. And we did have 3, constant 3. This one is 5 and natural log of x minus 1 and negative 1. And the same situation, x minus 1, we can rewrite as a u x squared, which is u to the negative 2. Integral of it is negative 1 over u, but this is my u, x minus 1. Okay, that means I can just rewrite as a negative 2 ln of x minus 3 of x plus 5 natural log of x minus 1, negative and negative will be positive. Okay, this is the final answer. Okay, this was case 2. Thank you.